Yes, Alfred, Tala, Baton, Musa, and some of your colleagues have forgotten their name. I'm back. Today I'm coming with similar bridge, 12 meter span, but with integral connection. Last time we talked about simply supported, where the elastic springs at this point was representing the elastomeric bearing, but this time it's the other way around. The deck slab and the abutment are monolithically cast. So if I can do this for you, then you'll be able to see what I'm meaning. That means the behavior of this bridge will be different from the previous one. So you can actually see that this is integral. In most cases, integral bridges are associated with pile foundation, but in this case, for purposes of sharing and understanding the basics, I maintain the spread footing anchored into the rock. But there's another model where I introduce the pile, and we shall look at it at a later date. So this is the integral bridge, slab bridge. What I want you to look at to know is with integral bridge, if I can quickly look at where there is a big fear now is the crack developed between the fill and abutment. Since the abutment and deck work in unison, so normally every time there is a deformation happening, moving in and out, you see that it creates kind of crack behind. So what is happening is there are two cases of minimizing or controlling the deformation behind, and that is done by one using approach slab, which is at the top of the road, unlike in most cases where you bury the approach slab under. Then for proper transition, and secondly, you can use stone-based material behind the abutment to control that. So basically like damp rock or stone dust properly graded, which is not the normal gravel we use for filling. So basically that is something that we need to take note of. If you look at the behavior of response to temperature, you realize that for simply supported, the temperature was more concentrated midway, and then now for this case, you find that we have fixed the deck at abutment area, and therefore there are free edges here. For those of you who do design of the two-way slab and the rest, there's where you call free edge and then rigid connected ends and the rest of it. So basically this is how you look at the behavior of the rigid connection. If you apply the vehicular load, you also see that basically that is how the vehicular load is. The stress distribution is more confined midway of the slab because of the boundary conditions at the bearings that have become fixed. If you look at them, the plate forces or the plate force, you realize that this time the moment tends to move away from mid-span towards the support, because that is where you have the rigid connection, and therefore takes up a lot of stress at that point. So when you look at this, definitely you see that this is how the whole behavior is. This is now the response of your bridge to applied load. So you see moment, this is only for live load. If I look at a combined load, you find that actually, there we go. You have the mid span is basically 300, but for simply supported mid span was about 900. So now you find that most of the stress has gone into the bending moment. At the rigid support. This is where you have, so you have to be careful when you are dealing with detailing and then locating reinforcement bar. Even the foundation of rigid pavement, rigid bridge tend to be more stressed than when it is simply supported. That is something also which we have realized. And then what is another difference that we took note of? I think I also needed you to have a look at how the abutment, normally we design abutment as a linear meter, but when you look at this, if you design a linear meter, you have to be very, very careful because you may end up underestimating reinforcement in some areas. So if you can look at this, the wing walls tend to cantilever outward. And yet in most cases we do cantilever going upward as more stress at the bottom, it decreasing down upward. But when you look at this scenario, it's the other way around. So we have to take note of that so that you're not able to make a mistake when you're doing integral bridge. Thank you.